on April 13th, 2026, Chinese automaker Geely stepped onto a stage and dropped a number that stunned the engineering world. For decades, many experts had treated this target as something that was effectively out of reach for a production engine, not just difficult, not just expensive, almost impossible. The number flashing on the screen was 48.41%. It may sound like just another technical statistic, but this figure could change the future of cars in a huge way. Here's what that number means in simple terms. When your car burns fuel, most of the energy never makes it to the wheels. A massive amount escapes as heat through the exhaust. More gets absorbed by the engine itself. Some is lost as parts rub and spin against each other. In many conventional vehicles from major brands like Toyota and Volkswagen, only around 30% of the fuel's energy is used to move the car forward. The other 70% is wasted completely. For more than a century, engineers have fought to reduce those losses. Every tiny gain took years of research and enormous investment. Until recently, the best thermal efficiency achieved by a mass-produced engine was about 41%. That was considered a landmark achievement and was widely seen as close to the practical limit for affordable production vehicles. Then Geely shattered expectations. Their engine reached a certified 48.41% thermal efficiency and earned official recognition from Guinness World Records. That is not a small improvement. It is a dramatic leap that has the entire auto industry paying attention. And the most shocking part is not just the record-breaking number, it is the clever engineering behind how they pulled it off. The story behind this breakthrough sounds almost unbelievable. It includes a tornado spinning inside a cylinder, an engine that runs hot and cold at the same time, and an 11-in-1 system that looks nothing like the engines most people know. It is a wild piece of engineering that has experts doing a double take. If you love technology stories that truly change the world, hit subscribe and turn on notifications right now. We cover major engineering breakthroughs as soon as they happen, and you definitely do not want to miss what is coming next. But before we get into the secret behind Geely's design, you need to understand just how shocking this number really is. To see why 48.41% has the auto industry buzzing, you first need to know why 41% was widely viewed as the practical finish line. Why was 40% considered the wall? Picture a combustion engine as a controlled campfire trapped inside a metal box. You inject fuel, it ignites, the expanding gases slam a piston downward, and that motion eventually turns the wheels. On paper it sounds simple, but here is the brutal reality. Fire creates enormous heat, and heat does not care where it goes. It spreads into the engine walls, into the cooling system, and straight out the exhaust pipe. Engineers are constantly trying to force that energy in one useful direction, but a huge portion escapes every single cycle. That struggle is governed by a famous law of physics known as the Carnot limit. You do not need to remember the term Carnot limit, but the idea is simple. Physics places a hard ceiling on how efficient any heat engine can ever be. The key factor is the temperature difference between the combustion event and the exhaust. The bigger that gap, the more useful work you can theoretically extract from every drop of fuel. But there is a catch. If the combustion temperature gets too high, engine components can be damaged. If the exhaust gets too cool, emissions control systems may stop working properly. That balancing act is why engineers at Toyota, Honda, BMW, and Volkswagen treated 40% efficiency like a giant concrete wall for years. Moving from 35% to 41% was not a small upgrade. It took decades of research, advanced materials, and billions of dollars in development. Every fraction of a percent became harder and more expensive to achieve. Toyota reached that milestone using a smart design called the Atkinson cycle. In simple terms, the intake valve stays open slightly longer than in a conventional engine. That reduces certain pumping losses and improves overall efficiency. It sounds like a tiny adjustment, but it helped Toyota's 2.5-liter dynamic force engine reach an impressive 41% thermal efficiency. When that happened, the industry took notice in a big way. Many engineers and analysts argued that pushing significantly beyond that level in affordable mass production would be extremely difficult. At the same time, automakers were investing heavily in electric vehicles, expecting battery-powered cars to dominate the future. As a result, some companies shifted fewer resources toward improving combustion engines. But that assumption left an opening. While many Western automakers focused on a fully electric strategy, engineers in China were exploring a different path. They asked a bold question: what if we redesign the engine from the ground up? That question started to crack what many believed was an unbreakable wall. And the first breakthrough came from a company that most people had heard of, but very few expected to shake the global auto industry like this. Before we talk about Geely's jaw-dropping 48.41%, we need to talk about 46%. That is where the story takes a dramatic turn. BYD, short for Build Your Dreams, looked at the traditional hybrid system and decided the old approach was no longer the smartest way forward. In many standard hybrids, the gasoline engine and electric motor can both help drive the wheels. That means the engine is constantly changing speed. It revs harder on hills, slows in traffic, and works through a complex transmission. Every time the RPM changes, the engine moves away from the narrow zone where it operates most efficiently. BYD asked a bold question: what if the engine barely drove the wheels at all during most of the trip? Instead, the engine could stay near one ideal operating speed and focus mainly on generating electricity. The electric motors would handle most of the driving while the engine performed a single job at the RPM where it was most efficient. That change was huge because the engine no longer had to react constantly to road conditions. BYD engineers could optimize it with far fewer compromises. They tuned it obsessively for one sweet spot instead of trying to make it perform well everywhere. The result was BYD's 5th generation DMI hybrid system, which achieved an extraordinary 46.06% thermal efficiency. That number sent shockwaves through the automotive world. A 5-point gain may sound small, but in engine development it is enormous. Toyota spent roughly 2 decades and invested billions to move from about 36% to 41%. BYD then pushed well beyond that benchmark and showed that the so-called efficiency ceiling was starting to crack wide open. BYD achieved its breakthrough in a surprisingly short time by taking a completely different approach. That caught the attention of established automakers around the world. For a moment, there was real concern inside the industry, but many companies returned to their long-term plans and treated BYD's success as something that might stay concentrated in certain markets. History has seen this kind of underestimation before. In the 1980s, some Western automakers dismissed Japanese manufacturers as a regional threat. We all know how that story turned out, but here is the twist. While much of the industry was still reacting to BYD's remarkable 46.06% efficiency, Geely had already spent 2 years developing something even more advanced. And the secret began in one of the most overlooked places in the entire engine, inside the cylinder itself. The tornado inside the engine. This is where the story gets truly fascinating. Geely's new IHEV system did not rely on a small tweak or software adjustment. It rethought how air and fuel are mixed before combustion even begins. That single change plays a major role in the engine's record-setting efficiency. Here is the challenge with a conventional engine. When air and fuel enter the cylinder, they do not always mix perfectly. Imagine pouring cream into coffee without stirring it. Some areas become concentrated while others remain thin. A similar pattern can occur inside an engine cylinder. That uneven mixture creates zones that are richer in fuel and zones that are leaner. When the spark plug ignites the mixture, the flame starts at one point and spreads outward across the chamber. This process takes time, and during those precious milliseconds, heat from the earliest part of the combustion event is already escaping into the surrounding metal walls. That means valuable energy is lost before the combustion process has fully finished. In engine design, every tiny loss matters. Geely realized that if it could make the air and fuel blend more evenly and burn faster, it could capture far more of the fuel's energy and turn it into useful motion. And that is exactly where the tornado effect comes into play. By the time the entire air-fuel mixture finishes burning, a large amount of energy has already escaped into the engine block as heat. That wasted heat is one of the biggest reasons traditional engines have struggled to move much beyond the 40% efficiency range. Geely's engineers tackled this problem with a system they call the Yufeng Tornado Combustion System, also known as the Fire Tornado. And yes, the name sounds dramatic, because the technology really is extraordinary. The intake ports were completely redesigned. When the intake valve opens, air is not simply drawn into the cylinder, it is guided into a high-speed spinning vortex, creating a tightly controlled tornado inside the combustion chamber. When the spark plug ignites the mixture, the flame does not slowly travel from one side of the cylinder to the other. Because the air and fuel are mixed much more evenly by the swirling motion, combustion happens far more quickly and uniformly. The result is a sharper, cleaner burn that pushes harder on the piston before excess heat can escape into the cylinder walls. That means less wasted heat, lower emissions, and more useful force sent directly into the crankshaft. Every part of the process becomes more effective, but this breakthrough introduced another major challenge. Higher compression and hotter combustion can increase the risk of engine knock. That is when parts of the fuel-air mixture ignite too early, creating intense pressure spikes that can severely damage engine components if not controlled. This problem has limited engine efficiency for years. Many experts viewed knock as one of the biggest obstacles preventing production engines from moving far beyond the low 40% range. Geely's solution was as innovative as the tornado system itself. The company developed a strategy that allows different parts of the engine to operate at very different temperatures, helping maintain high efficiency while controlling combustion more precisely. In other words, this engine is designed to run hot and cold at the same time. And that unusual balancing act is one of the key reasons it was able to achieve a record-setting 48.41% thermal efficiency. For years, this was the barrier. Engineers knew that increasing compression could unlock more efficiency, but pushing combustion harder also increased the risk of damaging the engine from the inside. That challenge is a major reason no mass-produced engine had moved beyond the low 40% range for more than 2 decades. Geely's answer was brilliantly unconventional. The company designed the engine to run hot and cold at the same time in different areas and completely by design. In a conventional vehicle, the cooling system circulates coolant through the entire engine at roughly the same temperature. It is a practical compromise, but it assumes every section of the engine has identical needs. In reality, different components perform best under very different conditions. So Geely split the cooling system into 2 fully independent zones. At the top of the engine sits the cylinder head, where combustion occurs. This area is cooled aggressively. Coolant flows rapidly through the head, removing heat as soon as it appears. Keeping this region cooler helps the incoming air-fuel charge remain denser and more stable right up to ignition. That reduces the chance of knock and allows the engine to operate at a significantly higher compression ratio than would normally be practical, and higher compression means more energy extracted from every combustion cycle. Meanwhile, the lower engine block is intentionally maintained at a warmer temperature. This is where the pistons move up and down thousands of times per minute. Why keep the section hotter? Because warmer temperatures reduce oil viscosity. Thinner oil allows moving parts to slide with less resistance, cutting friction throughout the engine. And friction is a silent thief. Every small reduction means more of the fuel's energy reaches the wheels instead of being lost as unnecessary heat. By cooling one area intensely and keeping another deliberately warmer, Geely optimized 2 conflicting goals at the same time. The result is a smarter thermal strategy that helps explain how this engine reached its astonishing 48.41% efficiency record. So now you have an engine that stays cool at the top to support very high compression while remaining warmer at the bottom to reduce friction. In traditional engine design, those two goals usually work against each other. Geely found a way to achieve both at the same time inside the same engine. The entire system is controlled by an electronic water pump and advanced software that monitors engine conditions many times per second. Coolant flow is adjusted almost instantly to keep each section operating in its ideal temperature range. It sounds almost too clever to work, and that is exactly why it has attracted so much attention. For years, many engineers believed the trade-offs would outweigh the benefits. Geely proved otherwise, but even the most efficient engine is only part of the equation. The next challenge is delivering that energy to the wheels with as little loss as possible. Rethinking the transmission. A highly efficient engine does not help much if a complex transmission wastes a large portion of that hard-earned energy. Traditional automatic gearboxes are impressive pieces of engineering, but they are also heavy and filled with components that create friction. Modern multi-speed automatics can include clutch packs, hydraulic systems, and many moving parts working together. Each component absorbs a small amount of energy. Those losses add up quickly. Some transmissions can weigh more than 100 kilograms. And even well-designed systems consume a meaningful share of the engine's output before power reaches the wheels. Toyota's hybrid system introduced the electronic continuously variable transmission, or ECVT, using a planetary gear arrangement. When it first appeared in the late 1990s, it was widely regarded as a breakthrough and helped define modern hybrid technology. But Geely believed there was still room for a more integrated approach. Instead of refining conventional layouts, the company developed a radically simplified system designed to combine multiple functions into one compact package. That decision did more than reduce complexity. It helped preserve more of the engine's record-setting efficiency all the way to the road. And what Geely built next may be one of the most ambitious drivetrain designs ever placed into a production hybrid. Geely believed modern hybrids no longer needed the weight and mechanical complexity of a traditional transmission, so the company started with a blank sheet of paper and designed something radically different. The result is the 11-in-1 EDHT intelligent drive system, and it is far more than a conventional gearbox. Instead of relying on a large transmission packed with gears and hydraulic components, Geely created what is essentially an electromechanical power router. It combines the engine, generator, two electric motors, high voltage inverters, and thermal management hardware into one tightly integrated housing. That level of integration delivers a major advantage. The total powertrain is about 13.5% lighter than many traditional hybrid systems. There are no bulky torques converters, no complex hydraulic channels, and far fewer components creating friction and energy loss. For roughly 90% of everyday driving, the gasoline engine is not mechanically connected to the wheels. Instead, it operates near its most efficient point and generates electricity. That energy is sent either to the battery or directly to the electric motors that drive the car. From the driver's seat, the experience feels remarkably similar to an electric vehicle. Power delivery is smooth, response is immediate, and the drivetrain remains exceptionally quiet. At sustained high highway speeds, the system changes strategy. Under those conditions, converting engine power into electricity and then back into motion can be less efficient than sending power directly to the wheels. So the system automatically engages a mechanical connection, allowing the engine to help drive the axle more directly. This intelligent switching helps maximize efficiency across a wide range of driving situations. Coordinating all of this is an advanced control system that evaluates operating conditions many times every second. It can use route information, battery state, speed, and terrain to determine the most efficient way to manage energy in real time. For example, if the system detects a long uphill climb ahead, it may decide to charge the battery in advance. If a downhill section is coming, it can conserve fuel and take advantage of regenerative charging later. This constant optimization is one of the reasons Geely's hybrid system is generating so much excitement. It does not just use advanced hardware, it continuously decides how to deploy that hardware in the smartest way possible. It is constantly analyzing the journey ahead and making decisions that no human driver could calculate in real time. And when all of Geely's innovations work together, the result is astonishing. The fire tornado combustion system, the split hot and cold thermal zones, the 11-in-1 EDHT drive unit, the intelligent power routing software. Together, these technologies helped Geely achieve a certified fuel consumption figure of just 2.22 liters per 100 kilometers. That number is extraordinary. It earned official recognition from Guinness World Records and pushed the boundaries of what a production hybrid vehicle can deliver. On a full tank and battery, the system is rated for a driving range of more than 2,000 kilometers. That is the kind of figure that forces the entire industry to rethink what is possible. What this means for the rest of the world. Battery electric vehicles offer clear advantages. They are quiet, highly efficient, and produce no tailpipe emissions while driving. For many people, they are an excellent choice, but there are also practical challenges. Large electric vehicles often require very heavy battery packs, and charging infrastructure is still developing in many regions, and long-distance travel remains a concern for some buyers. Geely's IHEV system points to a different route through the energy transition. For daily commuting, the vehicle can deliver the smooth and responsive feel that drivers associate with electric cars, yet it also offers an exceptionally long total driving range and the convenience of refueling at ordinary gasoline stations. That means no dependence on fast charging networks during road trips, and in many markets, operating costs that can be highly competitive. And this technology is not limited to a tiny city car. It is being used in a full-size SUV, a category typically associated with greater weight and higher fuel consumption. Despite that size, the vehicle is rated at less than 2.5 liters per 100 kilometers under standardized test conditions. That is a stunning result, and one reason this breakthrough has sparked so much debate across the global auto industry. For Western and Japanese automakers, this is a serious wake-up call. The internal combustion engine was born in Europe. Germany, France, and Britain led its development for more than a century. Japan then refined it with extraordinary precision over the next 50 years. Many believed the technology was already close to its practical peak. Now, the global efficiency record belongs to Geely, a company that had only a limited international automotive footprint just 15 years ago. That shift is turning heads across the entire industry, and this is not a gap that can be closed with a software patch or a flashy marketing campaign. Catching up requires new engineering strategies, fresh research, and years of investment. That is a difficult challenge when companies are also investing heavily in electric vehicles and trying to manage multiple technology transitions at once. For consumers, however, this competition could be fantastic news. When automakers race to outperform each other, prices often become more competitive and technology improves faster. History has shown this pattern again and again.
Me encanta el olor a...
Goma quemada por la mañana.
Established manufacturers will respond. The real question is how much the market changes before they do. What Geely has demonstrated goes far beyond a single record-breaking number. The company has shown that the combustion engine still had far more room for improvement than many people expected. The barrier was not simply physics, it was the industry's assumptions about what was worth pursuing. If you made it this far, you now understand more about engine efficiency than most people who casually follow the automotive world, and that is a powerful perspective to have. If you found this breakdown helpful, make sure to hit the like button, subscribe to the channel, and turn on notifications so you never miss the next major engineering story. We will be tracking how established automakers respond, and the next few years could reshape the car industry in a huge way. Now, I want to hear from you. Do you think ultra-efficient hybrids like this are the smartest bridge to an electric future? Or do you believe battery electric vehicles will advance so quickly that this technology becomes a short-lived detour? Drop your thoughts in the comments below. I read every one of them, and thanks for watching, and I will see you in the next one.